Hello, my name is Paul. Last time, I showed you the capabilities of XGL, a widgets library for Qt and JavaScript. Today, I am talking about layout trashing and how XGL prevents it. It is a technical subject, and I think you will find it interesting. A quick overview of the presentation. You will first learn what layout trashing is and what you shouldn't do in your Qt and JavaScript code. Also, if you don't know it, you'll discover what a browser's animation frame is. Then, I will explain how Presto, the XGL's component in charge of handling DOM reading and writing, works. Also, you will learn about the importance of throttling of events, which is an essential part of reactive user interfaces. Then, you will discover how easy it is to create smooth animation with Presto. And finally, I will tell you how to get Presto and XGL. What is layout trashing? Primarily, it consists in the repetition of two steps throughout your code. We will suppose the browser has already computed the layout, which is the size, the location, and visibility of all elements on the page. First, you read a value in the DOM. For example, you ask for the size and location of an HTML element, or you ask for the computed style. Secondly, you write something in the DOM. After the writing, the browser invalidates the layout. If you read something else from the DOM, the browser needs to recompute the arrangement of all elements, which can be an expensive operation depending on the complexity of your user interface. It is the infamous layout trashing. If you repeat multiple times these two operations, reading and writing, maybe in different, unrelated parts of your code, you can quickly crush the performance of your web application. A quick example of layout trashing. In this small JavaScript program, we trash the layout voluntarily. It is how you should never code. We create a centered div with round corners to be a circle. Then, we aggressively start to read the width of the div and set the size to be 1 pixel larger and higher, 300 times, to see layout trashing in action. After recording what the browser did, look how many times the layout is invalidated and recalculated. It has no significant impact with such simplistic example, but I let you imagine what would happen if you had hundreds of elements in the page. One more thing before we dive into Presto. What is an animation frame? The browser tries to refresh the screen at a fixed rate, 60 frames per second, or 1 frame every 16.7 milliseconds. Conveniently, the browser provides access to this animation frame, and you can execute your code when the browser refreshes the screen. Should you execute all your code inside an animation frame? No. What you should run is short pieces of code, nothing computationally heavy, first reading, then writing in the DOM. It has one huge benefit. At the start of the animation frame, all computed values are already available from the previous rendering cycle. Values you can read and then use to update your elements. Carefully done, the browser will love it, and your interface will be blazing fast. I know so far it is slightly overwhelming. However, don't panic. Presto will blow your mind how easy it is. How Presto works. First, we know there is a particular process in the browser called an animation frame we should use to manipulate the DOM. Hence, Presto operates inside an animation frame. Presto handles chiefly two operations: measures, which are everything you read from the DOM, and mutations, which are everything you write to the DOM. Presto processes all measures first, then it executes all the mutations. This sequence ensures two things. First, no layout trashing can occur within a regular Presto cycle. Presto will strictly enforce that no measure happens in the mutating phase and no mutation is allowed in the measuring period. Secondly, if your mutation needs a measure to be performed first, it will always be the case. Using Presto is straightforward. You call a method called scheduleMeasure to add a measure, and you call scheduleMutation to add a mutation. At the start of the animation frame, Presto will process all measures first, then all mutations in the DOM. This process is fundamental for XGL. XGL is developed using an oriented object approach, and the best way in object-oriented programming is when each object is aware of himself only, to have low coupling and more flexibility. And in XGL it is the case. For example, a scrollable panel doesn't need to know anything about the form that is inside. By using Presto and by asking it to schedule DOM operations, no component will invalidate the layout. And now, a quick illustration of what we have learned so far. As in the previous JavaScript program, we create a circle, here extending XGL widget class. Then, we add an event handler. When the mouse moves, we read the current width of the div with a measure, then, after the measure, we mutate the div by growing or shrinking it, and centering it under the mouse cursor with a mutation. Both the measure and the mutation are asynchronous and will occur in the next animation frame. The holder variable you see here is because all variables from the enclosing scope need to be effectively final in a lambda expression. The holder itself does not change, only what is inside. The result is, as expected, a growing and shrinking spot under the mouse cursor. About JavaScript. You can use Presto in your JavaScript web applications and get the same result, here with ECMAScript 6 classes. XGL calls the main function at startup. It is the same kind of code as in Java. And here, the same without ECMAScript 6 classes, but with standard ECMAScript 5 syntax. Presto has two more fundamental operations related to the scheduling. You can ask Presto to measure or mutate as soon as possible. If you ask Presto to measure as soon as possible, you have two possible outcomes. If you are already in the measuring phase, Presto will execute the measure immediately. If it is not the case, Presto will schedule your measure for the next animation frame cycle. If you ask Presto to mutate the DOM as soon as possible, you have three possible outcomes. If you are in the measuring phase, Presto will execute the mutation at the end of the measuring step, in the same animation frame cycle. If you are already in the mutating phase, Presto will run the mutation immediately. If you are not in the Presto cycle, Presto will schedule your mutation for the next animation frame. One quick warning: calling measure as soon as possible and then mutate as soon as possible doesn't guarantee that the measure will occur before the mutation. Anyway, asking Presto to mutate as soon as possible is very useful if your mutation does not depend on a measure. Now, a quick glance at mutate as soon as possible. We created a function drawing a circle at a random location, random size, and random color. First, we call this method at the start of the event handler. We are not in the mutating phase of the cycle, which means Presto will schedule it for the next animation frame. And we call it here, in the mutation. Hence, Presto will execute the method immediately. The result is random circles drawn on the screen. In JavaScript, it works the same as in Java. Sometimes, you have to execute your code synchronously. For example, when you want to call prevent default on an event. The browser needs to know if you are preventing the default action immediately, not in the future. So Presto has a method now which allows you to do anything you want synchronously. You should limit the calls to now to what is necessary only. Though be careful, you can do anything in this state and you can easily trash the layout. Don't forget, with great powers come great responsibility. Now method in practice. Here, we want to prevent the context menu from displaying only if the moving circle is larger than 100 pixels, then reset the size to 30 pixels. We have to use now to be able to get the size of the div element, then call prevent default if needed, synchronously. As you see, you can do anything, read and write. It is the same if you code in JavaScript. One quick word, XGL does not use the browser's context menu event. XGL has its distinct context menu event to have one source code working both on desktops and touchscreens. If you have a mobile phone or a tablet, XGL will fire the context menu event if you hold a touch. Now, one cool stuff Presto allows you to do without even thinking about it is event throttling. Some events, like scrolling, moving the mouse cursor, or resizing, can be fired by the browser at a very high pace. Since your browser will update the screen every 16.7 milliseconds, it is not only useless to process all the events, but worst, it can negatively impact your application. So, it is highly recommended to throttle or debounce those events. Throttling a function means limiting the number of times a function can be called over a period, while debouncing means imposing a minimum delay between two executions. Even if it looks complicated, it is incredibly straightforward to do with Presto. One crucial feature of Presto is that if you add the same measure or mutation object multiple times during the same period between two animation frames, it will be executed only once, which is what we need to do. Let's have a quick look at an example. We move the measure and mutation objects outside the scope of the event handler. We schedule the measure and the mutation by passing their reference. That way, even if the browser fires the mouse move event many times between two animation frames, the real handling will be performed once and only once, when it is needed. No surprise, you can do the same if your favorite language is JavaScript. Not only this code throttles or debounces the event handling, but it runs the event handling on the browser's ideal timing inside an animation frame. And it is easy. Animations with Presto. When you wish to animate components, for example moving a div, you have many options. Use CSS transitions, use CSS animations, or use Presto's animations. Animating with Presto is easy because it allows you to easily separate readings in the DOM, if needed, and writings in the DOM while benefiting of the browser's animation frame without even thinking about it. The only thing you have to do is to inherit from the class animation and override the methods you intend to use. For each step, the start, the intermediate updates, the completion, and even cancelling the animation, you can measure and mutate the DOM. Presto will handle the scheduling for you. We have reached the last demonstration of this video. In this example, we want to move a circle where we click, wiggling randomly. We create an animation by extending the class animation. We can specify the easing function to use. Then, we override the methods we need to use. Here, we want to measure something when the animation starts. We extend on start measure. Then, each time we have to update the position of the circle on the screen, Presto calls on update mutation with the progress, a value between 0 and 1. Finally, when the animation is complete, we update the circle to his final location. When we want to start the animation, we call the method run with the duration. Presto will handle everything. Here, Each time we click, if an animation is running, Presto cancels it and then restart a new one from scratch. On the JavaScript side, nothing different. You have here an example with ECMAScript 6 classes. And now, an example of how to do the same in ECMAScript 5. You are now wondering, can I get Presto and XGL to use it in my project? Yes, you can. I work on XGL full-time, and I need your support to continue to improve XGL and Presto. To become a sustaining member, it is simple. You can go to Xalys.com and go to the membership sign-up, or you can go to patreon.com/xgl. For a small recurring contribution, you will get XGL and all the future updates. Thank you for your support, and thank you for watching!